This video is just going to give you a little overview about what's going to be on the test 3, which covers chapter 5 and most of chapter 6. I'm leaving off a couple of sections from that. So I wanted just to make sure that you knew what was in which section of the book. So the first thing I want to kind of tie together for us is that sections 5.1 and 5.2, 5.3 and 5.4, all of chapter 5, as well as 6.2, which is on optimization. These three sections are all related to each other. These are related. Now, they're all related through derivatives and whatnot, but these in particular are not to be sectioned off from each other. So, basically, in section 5.1 and 5.2, we learn about the first derivative test, and this is what we have been doing, and this is what the first derivative looks like. And this is where we take the first derivative of a function, we set it equal to 0, and we find the critical values, and we test the critical values. So this is what these sections are about, and what does it tell us? Well, basically it tells us when a function is increasing or decreasing. So when the first derivative is positive, then the function itself is increasing, and when the first derivative is negative, then the function itself is decreasing. So that's what it tells us. We would take some critical value. Let's just say we had some critical value here. And we would plug C1 into the derivative, f prime of x. And if we got a positive value, let's say, when we took f prime of C1 was positive, then that would mean that the function is increasing. And if we took not C1, but something to the left, our test value to the left, so not C1, but whatever test value we got here, maybe A. And then over here, we would test another test value, B, and so we would put that into the derivative. And if that's, let's say that gave us a negative, that would tell us that the function itself was negative. And so what would that mean? That would mean at this critical value, there is a relative max, and we would determine that value by plugging that into the function itself has a relative max. Okay? Or for instance, let's just say that we found some critical value when we set the derivative equal to 0 and solved. And we plugged in some test value and we got a negative. That would mean that the function itself was decreasing. And we plugged in some other test value and we got a positive. I should have chosen E, not C, because we already have too many C's. And we got a positive. Then we would say, oh, the function is decreasing before we get to C2 and increasing after we get to C2. We would plug E and D into the derivative. Those are just test values. If we found that something significant was happening there, that there's a relative min at that point, then we would plug C2 into the function itself, and we would determine that, yep, at f of C2 is the value of a relative min, and it occurs at C2. So this is what it helps us know. Here are the examples I'll be doing in another video on page 330, number 29, and then we're going to cover page 331, number 63. Okay, in section 5.3 and 5.4 of the book, this is the second derivative test. And this is where we take the second derivative of the function, we set it equal to 0, and we solve for the critical values. What does it tell us? It tells us basically the shape of the graph of f. So if the second derivative is positive, then the graph is going to be in a concave up shape. Concave up. If the second derivative is negative, then the graph is going to be in a concave down shape. So again, we would, test our critical values. Let's say we had C1. If it was going from down to up or up to down. Again, whatever test points we would pick here, let's just say F and G. For either one of these cases, you plug these into the second derivative. You would test these. Oops. Oh, I shouldn't have chosen F. I keep picking bad letters. Let's say H. If this turned out to be positive, then we know it's concave up, and we would take G and stick it in the second derivative to determine whether it's up or down. If we notice a change in concavity at a critical value, either from up to down, or I did the same thing, or from down to up, let me try again, from down to up, we say, oh, that's significant. We have something called an inflection point happening at that critical value. That's what that would be, an inflection point. So we'd say F of C1 or F of C2 is an inflection point. And that is significant because it takes note of a change in the rate of increase or the change in the rate of decrease of a function. The examples we'll look at, first one's on page 331, number 41. The second one's on page 313, example 8. Okay, now, 6.2, what is this about? This is about optimization. And so what is happening in 6.2 is we're using this information up here in an application. Actually we're using this optimization has only really, we use it for the first derivative. And we use the first derivative test in a word problem to tell us what's going on. So the examples, so it's basically what we learned in 5.1 and 5.2, to find where is it going to maximize something or minimize something. And we do the same stuff. We test it. We see if there's a max or a min and determine this value would maximize it or this value would minimize it. Should be a point. And the examples that we're going to look at there, and this will be not on a video. So this isn't a video coming your way. This isn't a video I made today coming your way. This will be in class on Tuesday, and these are the ones we're going through. 12, 16, 18, and 20. We're going to do these together in class. And so all of these are tied together. So I'm going to make a second video to talk about the rest of the sections in chapter 6.